Today we're going to explore a little bit more into circles and specifically looking at lines that are tangent to a circle. And what that means is a tangent line is a line that touches a circle only once. So I've got a circle right here and I'm going to draw a line that touches this only once. So I'm going to put a dot right here on it and a line that touches once. And I can do better than that. There we go. Alright, so this line continues in either direction. This line only touches the circle once. So let's draw some other things that we recognize. So center of the circle, boom, right there. All right, so let's look into this a little bit more. So we've got a little indication here. The radius and the tangent line always create a 90-degree angle or a right angle. So remember, a radius goes from the center of the circle to anywhere on the outside. And let's draw it to that same point that we had on the tangent line. So they're saying that that radius and that tangent line are always going to create a right angle, a 90-degree angle. Okay? So that's something to remember there, 90-degree angle. So let's look at our first problem here. So we've got a circle, and what they're going to give us, a little point down here and a line that shoots off. We're going to call this AB. Now the question is line AB tangent to the circle? All right, there's going to be some more information that they'll give us here. So for example, there's the center, and they'll give us the radius. All right, they tell us from A to B is, let's see, 13 is the length of 13. The radius is 8, and they also tell us that the distance from the center to outside B over here, outside B over there, is 17. All right. Now, this tangent line looks a little bit different than the one we did before. I can extend it, and you see that it is a fully continuous line. So the question is line AB, that red piece, tangent to the circle? Does it only touch it once? So the real thing to analyze here, does it make a 90-degree angle with the radius? So it's asking right here, is that 90 degrees? We don't know just yet. But if we look at it and kind of ignore the circle and highlight everything else, we have the radius, we have this AB line, and we have the connecting line there. We've made ourselves a triangle. And on that triangle, we have three sides, the 8, the 13, and the 17. Three sides of a triangle, and we're guessing something about this angle here. Maybe it's 90. That sounds familiar from something we used before. Remember our Pythagorean Theorem? We're going to use Pythagorean Theorem here to find out if that angle is 90 degrees. And remember that formula is a squared plus b squared equals c squared, where c is the most important side, the hypotenuse, so c would be 17. A and b really don't matter, so I'll go a here and b here. So let's plug those numbers in. So we've got 8 squared plus 13 squared, and c squared is 17 squared. Now in the middle here, I don't know if it's equal yet. Okay, I don't know if it's a right triangle. I don't know if Pythagorean Theorem is going to work out yet, so I'm going to put in a blank here with a question mark. If we find out that they are equal, then it is a right angle. If they are not equal, then it's not a right angle. And that'll help us answer our question from earlier. So let's work out the math here. 8 squared is 64. 13 squared is 169. Still don't know yet. And 17 squared is 289. Yep. All right, we're going to go ahead and add these two together. 64 and 169 comes out to 233. We've got 289 over here, and well, look at that. Are those two numbers equal? No, they are not. So they're not equal. So we'll ask ourselves our questions here. If they're not equal, Pythagorean Theorem did not work. So if Pythagorean Theorem did not work, did it make a right angle? No, it did not. And if it didn't make a right angle, is that line tangent to the circle? No. So if Pythagorean doesn't work, it's not a 90-degree angle, it's not going to be tangent. So in the end, the answer is no. That line is not tangent to the circle. All right. So if you want to simplify all this, basically do Pythagorean Theorem. If the two numbers are equal, say yes. If the two numbers are not equal, say no, not tangent. All right, so let's try this again. So for example, let's get ourselves another circle here. It's a pretty good one. All right, so this time they're going to give us a line down this way. Okay, we've got A, we've got B, we've got the center of the circle, and they'll connect these two. Let's give them some distance here. We got 3, we've got 4, and then this distance here is going to be 5. So we're trying to find out, does this make a right angle or not? And in order to do that, we need to find out Pythagorean's theorem. So is AB tangent? So let's plug it into Pythagorean theorem. Okay, because you see they always give us 3 sides here. C is the biggest side, the hypotenuse, so that has to be the 5. A and B really don't matter, so I'll just go in order. 3 squared plus 4 squared. Can't put equals yet, because we don't know. 5 squared. So 3 squared is 9, 4 squared is 16, don't know yet, and 5 squared is 25. We're almost there. So over here we get 25 and 25, so yes, they are equal this time. So if they are equal, that means Pythagorean theorem did work, which means this is a right angle, which means yes, AB is tangent to the circle. Okay, so we've seen a no, we've seen a yes. Let's just take a look at one more to kind of wrap this all up. Okay, we got the center of the circle. Got that. A, B. Okay, let's put some distance on these. So we've got 12. From here to here is 20. And that is 7. Okay. Now we're trying to find if AB is tangent to the circle, so we're trying to find out if this is a right angle or not. We're going to use Pythagorean's theorem. So A squared plus B squared equals C squared. Now this time it's a little bit different. My triangle cuts through the whole circle. So I'm going to highlight it this time. We actually got to use all these ones. So I've got 7, 12, and 20. The biggest side, according to this, is 20, so let's call that C. A and B really don't matter. Let's call that A. But what's the issue over here? 7. That really just indicates right here. You see how it's only marking there? We need the whole distance. We need from, let's get a new color. I need from here to here. 7's only marking the radius. But if I know from here to here is 7, this is also 7, so the full distance should be 14. So that's actually my B there. Okay? So sometimes we might need to do a little bit more work. So A is 12 squared plus B is 14 squared. I don't know if it's equal yet. C is 20, but squared. Alright, let's work the math on it. 12 squared is 144. 14 squared is... why am I going blank on this? 14 squared is 196. Don't know if it's equal yet. And 20 squared is 400. That one I do know. Alright, so let's go ahead and add these up. 144 plus 196 gives me 340. And we got 400 over here, so are they equal? No, they are not. So if they're not equal, Pythagorean's theorem does not work, meaning it's not a right angle, meaning that no, line AB is not tangent to the circle. All right? So, long story short, use Pythagorean's theorem. If the two sides are equal, yes, it's tangent. If the two sides are not equal, then no, they are not tangent.